rest of 4.2 and 4.3 that we didn't quite get to cover on Monday in class. I wanted to start off today by going over two theorems that we rushed through kind of at the end of class, and I just want to make sure that you have those recorded down. The first one is theorem 4.3, which is the third angles theorem. So basically what this theorem says is that if you have two angles of one triangle that are congruent to two angles of another triangle, then the third angles are also, and the fill-in there is, those two are also congruent. Okay, and this makes sense, right? So what it says is that we have angle B is congruent to angle E. We have angle A is congruent to angle D. And so if two of the angles are congruent to each other, then the third angle, which is C and F, are also going to be, angle C and F are also going to be congruent to each other. So this makes sense just knowing our knowledge about triangles, right? If A and B, or A and E are congruent and E and D are congruent, that means that they're equal. And by using the fact that they add up to 180 degrees, we can prove that the other two angles that are left off, the third angle, is also congruent. So that's one for your notes. The other one is some properties of congruent triangles. And these are the same exact properties that we did for lines and angles, and now we're talking about triangles. So the first one is reflexive. Reflexive just basically says if you have triangle ABC, it's congruent to triangle ABC. Okay, and symmetric, remember symmetrical. So if you have triangle ABC is congruent to triangle DEF, then triangle DE, I don't have enough space here, DEF is also going to be congruent to ABC. Works both ways, right? And then the last one says that if you have ABC, well, let me I should be using my draw lines here. Let me go back a few. So it says ABC is congruent to DEF, and DEF is congruent to JKL. That means that triangle ABC is congruent to triangle JKL. So just make sure that you have those in your notebooks and your not in your notebooks, in your reference guide for your theorems, and update those. Okay, so let's go ahead and do a couple problems that have to do with congruent figures, which is what we were talking about in 4.2. So these aren't necessarily congruent triangles all the time, but we're talking about how do congruent figures, triangles, all that correspond. Now there's one part that is left off the notes here, which is that in this particular case, switch over to my brush, figure F, G, H, J is congruent to S, T, U, V. Okay, so what they want you to do is identify all the corresponding angles and the corresponding sides. So one nice thing about when you have a congruence figure that's stated like this is that you can actually look at the picture, or you can look at the statement to figure out, okay, what are my congruent angles and my congruent sides? So I think the easiest thing to see from the diagram here is that F and S appear to be the congruent figure or congruent angles in this particular figure. And that actually matches up because F and S are in the first position on the congruent statement. So we could say that angle F is congruent to angle S. The other one that's really, really obvious is H and U, because those are both right angles. So we could say that angle H is congruent to angle U, and those also match up in the congruent statement. If you're good at visualizing things, you might be able to visualize this flipping over. If not, you can look at the statement. So we could also say that angle G is congruent to angle T. So it's kind of this figure looks like it's been rotated about maybe 200 degrees. It looks like it's been rotated all the way around. So if you kind of picture that, you can see that G and T are the congruent angles. And again, if you can't visualize that, they're in the same position. And that means that angle J is congruent to angle V. So those are our corresponding angles. And then we can look at our sides. And again, we can do that the same way. We can visually figure out what our corresponding sides are, or we could actually just use our congruent statement. So we could say that FG is congruent to ST. So FG is congruent to ST, and we would show that with like a little mark, remember? And then, let me undo that because I'm crossing out. We've got GH, right? GH is congruent to TU, and it's important to do these in the right order. So you wouldn't say that GH is congruent to UT. You would say to TU. So you want to follow the same order. Okay, and then we have HJ is congruent to UV. And lastly, we have that JF is congruent to VS. So that would be all of our corresponding sides. And then the last thing that they asked us to do in number 2 is find the value of X and find the measure of G. Okay, so I kind of wrote over things here a little bit, but really we're trying to figure out what is the measure of angle G, okay, and to figure out what X is. Well, we know from all of our work here, right, that angle G is congruent to angle T, and we know that the measure of angle T is 103 degrees, even though I just wrote over top of that 103 degrees. So actually by we can say that G is congruent to angle T. And by the definition of congruence, we can say that the measure of angle G is equal to the measure of angle T, which we know is 103 degrees. So we know that G is 103 degrees, right? Measure of angle G is 103 degrees. We also know that G is 2x minus 7. So if we want to find X, we just say, okay, well, G is 2x minus 7. And we also know that it's 103 degrees. I really want to write 130 for some reason. So we can solve this, right? We're going to add 7 to both sides, and we'll get 2x equals 110, or x equals 55. 5. All right, so that's how we can use our understanding of congruence. And then there is one more example in 4.2 that I wanted to go over where we can actually use the third angles theorem to solve. So let me pull that up. Pull that off of here. I'm going to try to draw this picture a little bigger too. So what they've done is we have a figure here, and we want to find the measure of angle V. So you can actually see, if you start looking through here, they kind of give you the steps as to how they're solving that. Now, you may not follow these exact steps. Like I know in my brain, I went a little bit different direction, and that's okay. But we're going to follow along in these steps just so we can kind of keep with the rationale, and then you can, if you would have solved it slightly differently, that's okay too. So let me get everything labeled here a little bit bigger. 66 degrees and 44 degrees. Okay, so what they ultimately want you to find is the measure of angle V, this angle right here. So the way that they have started tackling this problem is to look at angle SUT and angle VST. VUW. So the first step here in the red, they're looking at angle SUT and angle VUW. So those two angles they're saying are congruent. And why can they say that those two angles are congruent? Well, the reason that we can say that this SUT and VUW are congruent to each other is because they are vertical angles. So we can say that these are congruent by vertical angles theorem. Okay. And then the next thing that they tackled is that in the diagram, it shows that angle STU, is congruent to, and then they leave a blank space. Well, this is actually something visually we can see, right? They've shown this symbol for congruence in this angle to this angle. So STU is then congruent to VWU, angle VWU. So now we actually have two angles that are congruent to each other. And by theorem 4.3 that we reviewed at the beginning, that if we have two triangles that have two angles that are congruent, then we can say that the third angle is also congruent. So the third angle would be angle S, right, is congruent to angle V. And the reason that we can say that is by theorem 4.3, the third angle theorem. Okay, so then let me mark that on here. This angle is congruent to this angle. Very colorful, right? So this is where I diverged a little bit from how they solved it, but either way is okay. So what they chose to do is to say, okay, well, I think I can figure out what the measure of angle S is. And I can do that by using a different theorem, which is the triangle sum theorem. I believe that's 4.2. And that tells me that if I have a triangle, all of the interior angles add up to 180 degrees. So what they're saying is that the measure of angle S plus 44 degrees plus 66 degrees adds up to 180 degrees. And that is by the triangle sum theorem. And that's actually what we would fill in right here. So we know that the measure of angle S, if you do the math here, is actually 70 degrees. Okay. And then they conclude the measure of angle S is equal to the measure of angle V, which is equal to 70 degrees. And we can say that because S and T are congruent to each other, and the definition of congruent angles is that if the angles are congruent, then their measures are equal to each other. So that's how we can use that to solve. All right, so that is the end of 4.2, and now we're going to switch over to 4.3. So 4.3 has to do with one particular postulate, so we're going to talk about that first. And, oops, closed out of Paint. Open that back up. We are actually going to cover several of these postulates over the next week or so. So this is the first of several. So all of these postulates are basically ways to tell if a triangle is congruent to another triangle. So this is the first one, which is called the side, the SSS congruence postulate. So what this says is that if we have side A, or excuse me, side AB is congruent to side RS. It'll let me right here, RS. Okay, and we have that side BC is congruent to side ST. I'm running out of room already. And we have that side CA is congruent to TR. So basically all 3 sides are congruent to each other, then we can say that triangle ABC is congruent to triangle RST. Okay, so I think this is pretty straightforward, right? If you have two triangles, all 3 sides are congruent to each other, then we can conclude that those 2 triangles are congruent to each other. And then in 4.4, we're going to talk about some other ways. If you have 2 sides and an angle that are congruent, then those triangles are also congruent. So there's different ways to prove that triangles are congruent. This is the first way we're going to talk about. Postulate 19. 3 sides are equal, then that means that the 2 triangles are congruent. I should say 3 sides are congruent. The triangles are congruent. Okay, so let's do a couple examples with this and get you guys on your way. So the first one is kind of a little proof, but I think it's actually pretty straightforward. Let's save. Okay, so it says use the side congruence postulate to prove that FGJ is congruent to HGJ. Okay, so we see here you've got a single triangle. Let's try to draw this nicely a little bit bigger here. That'll work. Okay, we've got a triangle that looks like it's right there. Okay, and we've got J, right, H, G, and F, and it looks like these 2 sides are congruent. So what's given is that FJ, this line along here, right, FJ, is congruent to HJ. Okay, that's already shown. And we also know that G is the midpoint of FH. So what we want to prove is that the 2 triangles that are formed are congruent to each other. So let's see this quick little proof here. It says that FJ is congruent to, and this would be HJ, right? That's what's given to us. And then point G is the midpoint of FH. So if you remember the definition of a midpoint, if you have a point in the middle of a line, that means that the 2 segments that it creates are congruent to each other. So FG is congruent to GH. All right, so we have one side that's congruent, 2 sides that are congruent, and then we have GJ, the line that goes down the middle. And by the reflexive property that we just learned, right, we can say that these 2, GJ is congruent to GJ. So now we have 3 sides. All 3 are congruent to each other. So by postulate number 19, the side, we can conclude that FGJ is congruent to HGJ. So pretty easy little proof to show that that's true. Okay, a few more examples and we will be done. Okay, so the next 2 don't actually have directions, but basically we want to say, can we say whether or not these are, that's not what I want to do. If these 2 are oh, there we go. Can we say if these 2 triangles are congruent or not? So can you say that JKL is congruent to MKL? So JKL, is that congruent to MKL? All right, so what we want to do is we want to look at congruent sides. So they have this label that JL is 9 and LM is 9. Those appear to be congruent because of the definition of congruency, right? If they're equal, they're congruent. JK and KM are congruent, and LK and LK are congruent by the reflexive property, right? And so since we have 3 sides, by postulate 19, we can say that this is true. Okay, so next up we say, okay, we have triangle RST. So RST. And then you have to notice where we're actually looking here. RST is congruent to TVW. Okay. So we need to figure out if those two are congruent. Just by looking at it, doesn't look like it, but maybe they've rotated something and they actually are congruent, right? So what we do know is that RT is congruent to TW. And I'm doing this by the diagram, right? And we know that ST is congruent to WV. And we want to know is RST congruent to TVW. Well, right off the bat, we actually don't know if the third side is congruent to each other or not. Even if you're saying, well, if two sides are congruent, is the third side congruent? We haven't actually proved that yet. But one thing to note is that RT is congruent to TW and ST is congruent to WV, but we don't know if RS is congruent to TV. We just don't know. It's not been stated. So we don't know if this is true yet or not based off of the information that we have. Okay, last problem is a little bit tricky, but not too bad. So we have a coordinate plane here. I'll try to make it slightly bigger. Nope, didn't work. Okay. Oh, I could zoom in a little bit. There we go. Really big. Okay. Determine whether PQR is congruent to the other triangles shown in the right. So in order to show with the information that we have, we don't know any angles. We do know the coordinates of all these points. How can we show if these triangles, there's 3 triangles, right, are congruent to each other? And the way that we can do it, given the information we know so far, is to see if they have the same, if all 3 sides are congruent to each other. So now we have to figure out, we have 3 triangles, 3 sides each, so we need to see if any of the sides are congruent to each other. There's a few that are really easy, so we're going to mark those right off the bat. So PQ, the length of PQ, if I get my brush here, PQ is a length of 3. So that's an easy one. RS is a length of 3. And QR is 1, 2, 3, 4, 5. The way that I'm finding these is I'm just looking at my grid and I'm counting 1, 2, 3, 4, 5. Okay. If you really wanted to be fancy, you can make like a grid ruler and you can measure this and figure out the other sides. But mathematically, let's start with PQR and SRT, those 2 triangles. And let's see, we have a third side here that we don't know the length of. But if we can prove that these 2 sides are congruent to each other, then we can prove that the 2 triangles are also congruent to each other. So how do we find the length of PR? Well, we do that using the distance formula. So what that is we do the change in x plus the change in x squared plus the change in y squared, all take the square root. So for this particular one, P is at -3, +5, and R is at 2, 2. So the change in x would be 2 minus a -3 squared plus the change in y, which would be 2 minus 5 squared. And we're going to end up with basically 5 squared plus -3 squared. And when you actually calculate that out, you get right about 5.83. So we know that this is 5.83. If we can show that TS is also 5.83, then we can say that those 2 triangles are congruent. So how do we figure out TS? the same exact way. T is at 2, -3, and S is at 5, 2. So change in x would be 5 minus 2 squared plus 2 minus a -3 squared. And we end up with 3 squared. I'm running off the page. 3 squared plus 5 squared, which all. So TS is also 5.83. So by the side postulate, postulate 19, we can definitely say that PQR is congruent. So PQR is congruent, and now we have to match up our points here, right? Is congruent to triangle SRT. Now, what about this poor triangle that is down here that we haven't given any attention to? Is this one congruent as well? Well, we would do that by finding the length of one of those sides. So we could pick WR, VW, any of those. So I am going to choose to do VR right here, and I'm going to scroll down and give myself some room. So VR, V is at -3, -2, and R is at 2, 2. So the distance from V to R would be -3 minus 2 squared plus -2 minus 2 squared. And I get -5 squared plus -4 squared, which works out to be 4.12. So the distance from V to R is 4.12. And 4.12 doesn't match up with any of my sides on my original triangle that I'm trying to be congruent to. So we can say that VRW is not congruent. All right, so that is the fun that is 4.2 and 4.3. Thank you guys for listening. Hope you have a good day. Bye.